AP Calculus Kids. This is Dr. Callahan with week 12 Wednesday. How are you guys doing? Go ahead and pause the video and answer the following 3 questions for your warm-up log. Okay, so for today, you guys do have your assessment on AP College Board. It is right over here for week 12 Wednesdays. It's 10 questions, and the topic is finding the volume by disc washers and cross sections. It is due by Tuesday, 11:59 p.m. in week 13. So you have exactly a week to complete this. So make sure you guys complete it. It is out of 10 points. And multiple choice. So today, before we actually get started with this, I do want to have you guys go over the 3 different methods so you can kind of compare it side by side. So here I have 3 questions, and looking at this, it's asking several ways of thinking about like what method is it, disc washer or cross section, what is your diagram, which formula are you going to use, what is the axis of rotation, are you solving x for dy or solving for y, oops, I spelled that incorrectly, for dx, what is your radius, what is your upper and lower bound, and all of these things matter because remember, if you're looking for the radius, your radius could either be like a rectangular one that is going to be vertical, or it could be horizontal. Okay, now most likely if it is going to be horizontal, your axis is going to go around in this direction, and if it's vertical, it's going to go up and down in this direction. So it's really important that you guys understand the differences there so you can match them to the equation itself. And also your upper and lower bound, if it is going to be like this where it's going up and down, then your integral is going to be from x1 to x2, and then if it's going to be like this, it's y1 to y2. So it's just really important that you guys are careful with it. All right, so then with that said, let's start off with the first one, which is right there. Your first equation, you have 2 of them. You could pick either or left or right, and it says find the volume of the solid. And basically, it is giving you that the volume of solid evolving around the y-axis. So first, we're going to draw the diagram. And I am going to do, I think I'm just going to do 2, okay? So y equals 4 minus x squared. Just keep in mind that this is going to be like a sad face, absolute value. It's going to start at 4, obviously, and then it's going to go down like this. So this is y equals 4 minus x squared. And it is revolving about the y-axis. So your y-axis is this axis right here. Your graph is going to be going around like this. So if it's going to be going around like that, just remember your radius that you're going to be using has to be a horizontal radius like that, because in order to revolve around the y-axis, it has to go in kind of like a circular motion. That's what you have right there. And if it's the y-axis, just remember that y-axis means that your x is equal to 0. All right, so with that said, you want to go back to your equation and you ask yourself now the questions. Which one are you going to be using? Are you going to be using the one that's solved for y or the equation that is solved for x? Let me go ahead and just paste this down here. So then looking at this first part right there, and I should probably move that down a little bit because you can't see the questions then. Okay, there we go. So looking at this here, just make sure I have the right one. Okay, you are going to use a disc method, and I know it's the disc method because there's just one rectangle. We did draw the diagram. The formula, which formula are we going to use? Well, given the fact that it is a rectangle that's horizontal and the axis of rotation is vertical because it's the y-axis, it's going to be the second equation right there. Okay, we're going to be solving everything for x in terms of y, and my radius is going to be a horizontal radius like this. I'm going to use r of y, and the upper or lower bounds, remember this is going to be y1 and y2. So I'm going to go back to my equation here. So then looking at this here, I want to make sure everything is solved for x, and I can see that this one, it is not. So I'm going to move my x squared equals 4 minus y, x equals plus or minus the square root of 4 minus y. Just so I solve for x. Here in the red one, x is equal to 0. Now let's take a look at the bounds, upper bound and lower bound. It appears that it's starting at y equals 0, and it's going to y equals 4. Yeah, that looks correct. And if you don't believe me, you can find the intersection of this red line and this green line, in which case you have two different equations, this equation and this equation. So you set the x's equal to each other, which would be 0 is equal to plus or minus the square root of 4 minus y. I will square both sides, 0 equals 4 minus y equals 4. So same thing. All right, so now let's go ahead and find the volume. Volume, the equation is volume is equal to pi integral from 0 to 4. And it is r of y squared dy. So your r of y is going to be the side here. It is going to be from right minus left. So the right side is touching the green line, and that green line is x equals the square root of 4 minus y. Minus the left, it's touching this red line, which is x equals 0. So r of y is just square root of 4 minus y. Well, let's plug that in here. Well, when you do that, you have to square it. If I square the square root times square root is just 4 minus y. So volume equals pi integral of 0 to 4 minus y dy. If I integrate this, I have 4y minus 1/2 y squared, evaluated from 0, 4. Now my upper bound is going to be 4. So 4 times 4 is 16 minus 4 times 4 is 6. 4 times 16 is 16 divided by 2 is 8. So that is just going to give me an 8. Minus my lower bound 0, and guess what? It's just minus 0. So my answer in this case is just 8 pi unit cubed. Now that I've done this one, if you want to try the first one on your own, you're welcome to do so. Pause the video. And then here's your answer on the left side. All right, so let's go ahead and go to this one then. In the middle. The middle, we're going to do a one that is going to be a washer so that we can see the difference of how the disc and washer correlates with each other. Okay, so here is the washer method. I have two different equations. Okay, I'm going to go ahead and do the A one right here. So let's work on A. So it says let R be the region enclosed by the function x squared plus 2. So that's going to be a parabola. And that parabola is going to be this piece right here. So y equals x squared plus 2. The horizontal line y equals 2. So y equals 2 means that it is going to be at like right here. Y equals 2. So this green line. And it is vertical lines 0. X equals 0 is right here. And x equals 4. I'm running out of colors. Let's do purple for this one. I need to figure out where it's going to be rotating. And it says it's revolving around that line x equals 5. x equals 5, so it's evolving around this line right here. And if you can imagine, this graph is just going to go in a circular motion around here. Okay, so given the fact that my axis of rotation is a vertical line, I want to go back here and figure out if my axis of rotation is a vertical line, I'm going to use a second equation. So that means I'm using the washer method. I already drew my diagram. My formula is going to be right here. My axis of rotation is vertical, and it is a line that goes up and down. I'm going to be solving for everything with x equals in terms of y. My radius is going to be a horizontal radius, and I'm looking at r of y minus lowercase r of y. And my lower bounds are going to be y2 and y1, like so. Okay, so now that we have that figured out, let's go ahead and draw our radius, or radii, I should say. So the first radius that I'm going to draw, and keep in mind that you do have your axis of rotation right here with x equals 5. So this is x equals 5. My first one that I'm going to draw, it is going to go touch the red graph to the blue line right there. And then my second one is going to be at this purple line to the blue line right there. So then let's go ahead and make sure that everything is solved for x. So I'm going to rewrite this one. So y minus 2 equals x with a square root. So that's solved for x. Everything else is solved for x. I think we are good. And now I need to find my intersection. My intersection looks like it's starting out y equals 2. But then my question is, how far does it go up? I'm looking at the intersection between this red line and this purple line. That's where it is. It kind of looks like it's at, I don't know, 16, but I'm not sure. So then what you want to do is you want to find the two x values, or the two equations solve for x. Now for the red line, it is square root of y minus 2. For the purple line, it is x equals 4. Let's set them equal to each other. So I'm going to put the intersection. So I have square root of y minus 2 equals 4, square it, y minus 2 equals 16, add it, y obviously equals 18. So I was somewhat close, but not all the way. All right, so that's my upper and lower bounds. And now let's find r of y, capital R of y. Capital R of y, because this is a vertical axis of rotation, it's right minus left. So the right side touching the blue line, that's just 5. Minus left, it's touching the red line, and that's square root of y minus 2. Then your lowercase r of y is going to be this tiny little rectangle. Right side is the blue line, which is 5, minus the left, and it's touching the purple line, which is 4, and that's just going to give you a 1. Your equation here is volume equals pi from 2 to 18. And it is going to be r of y squared minus lowercase r of y squared dy. Well, for this one, lowercase r of y squared is just 1, but the upper r of y squared, you will have to go ahead and FOIL that. So let's do that. 5 minus square root y minus 2 times 5 minus square root r minus y minus 2. Okay, so when we FOIL this, 5 times 5 is 25. Minus your outer is going to be a negative times 5, so negative 5 square root of y minus 2. Inner is a negative 5, so add it together, negative 10 y minus 2. And then square root of y minus 2 times the square root of y minus 2 is going to be a positive y minus 2. So it's kind of a little bit difficult to redo here. Let me go ahead and rewrite that. So 25 minus 5 is going to give you a 23 minus 10 y minus 2 to the 1/2 plus y. And so volume equals pi from 2 to 18, 23 minus 10 y minus 2 to the 1/2 plus y dy. Integrate this, plug it in, and then when you do that, you should have the volume is equal to 85.33 pi unit cubed. All right, now let's take a look at the last one, which is the cross-section one that we talked about from yesterday. Now with your cross-section one, this is the example that I have. I want you guys to go ahead and take a look at the answers for the area of the formulas for the cross-section. We identify square, isosceles, right triangle, isosceles, right triangle, hypotenuse, rectangle, equilateral triangle, and also semicircle. And for this example, it's asking you to go ahead and find the volume of the solid if the base is bounded by the curve y equals square root of 1 minus x squared, y equals 0, x equals 0 in the first quadrant, and the cross-section are squares parallel to the y-axis. All right, so let's draw the diagram. So it's y equals 0, x equals 0. So here you have the x-axis, y equals 0, x equals 0. Square root of 1 minus x squared is just going to be kind of like a graph that looks like this. So you're going to start up at 1, and it's going to be a sad face going downwards. So this equation here, and I'm going to change the color of that, is going to be y equals square root of 1 minus x squared. So your rectangle here is going to be right here. Oh, and because it says, I shouldn't just assume that, it's a square parallel to the y-axis. So given the fact that this is the y-axis, its vertical goes up and down, your rectangle has to be parallel to that. So then that means it is going to be rotating around like this. And if you can imagine, you have a pane of a rectangle glass. That's right here, rotating about here. Okay, so then if it's rotating around the y-axis, it is going to be this one right here. Well, actually, no, it won't be that one. I'm sorry, I'm doing this incorrectly. It's parallel, so it is going to be rotating. It's going to be rotating like this way. There we go. So alongside the x-axis. So then we're going to be using this equation right there. Okay, so then let's go ahead and take a look at the base. The base is going to be a top minus bottom. So the top, it's touching the green part, and that is, and everything's with this one has to be solved for y in terms of x, which it is. So square root of 1 minus x squared minus the bottom. Bottom is y equals 0, so minus 0. So that's just going to be 1 minus x squared. Now the area, which is going to be a square, and remember for a square, the area is base squared. So my base is just going to be square root of 1 minus x squared squared. So that's just going to be 1 minus x squared. Now let's take a look at the volume. The volume formula is going to be the integral from x1 to x2. I know it starts at 0, but then I don't know how far it goes up here. I think it's at 1. But then again, if you're not sure about that, you can find the intersection between the green and the red line right there. So it is just going to be square root of 1 minus x squared equals 0, square 1 minus x squared equals 0, 1 equals x squared, x equals 1. So 0 to 1. And your volume is going to be, remember, it's going to be the area of the cross section. Area of the cross section is 1 minus x squared dx. So then let's find the evaluate this from the integral. Have x minus 1/3 x cubed evaluated from 0 to 1. Your upper bound is just 1 minus 1/3, which is a 3/3, which is a 2/3. Minus the lower bound is just 0. So my answer is 2/3. Notice there's no pi, unit cubed. All right, so now that we've gone over all 3 different methods, keep in mind that we went over the disk method, washer, and then cross-section. You guys should have a pretty good idea as to what we're doing and how they kind of relate to each other. So now that we've done that, you guys can go ahead and get started on your quiz right here. And it's 10 questions. All right, you guys, as always, stay safe and healthy. I'll see you guys next time. Take care.